exponents are not just powers, so it's not just 2 to the power 4, but it's surds as well, which are square roots and cube roots. So there's something to do with surds today that I want us to cover that I feel is important under the section of exponents. Hello, Linamta. Hello, guys. Hello to everyone who joined after I greeted. Okay, so let's get going. So this is what you guys were doing on Tuesday, exponential equations. Okay, so I have here 8 to the power of x is equal to 64. How are we going to solve this guy? How are we going to solve this? Firstly, we need to do what? We have 8 on the left-hand side, and we have a 64 on the right-hand side, which is a problem for us. What do we want in order to solve this equation? Anyone? Something we need before we can solve this equation? Does anyone have an idea what I'm talking about? We need the same base, right? We cannot solve this with 2 different bases. So which base are we going to use? We have an 8 and we have a 64. Which base do you think is best to use in the 1.1? We're doing 1.1 now. Anyone? Okay. So if you don't know, you go on your calculator. 8 squared. Thank you, Butlali. We're going to use 8 squared, right? So we're going to say 8 to the power of x is equal to 64, which is the same as 8 squared. Now that we have the same bases, what can we do with my exponents? We have the same bases, so my next step is to do what? Anyone? If you have the same base, you can drop the base, can't you? And then you equate the exponents. So then you can just say, therefore, x is equal to 2. So number 1, first step is we want the same base. Right? And then number 2, once your bases are the same, you drop the base and you equate your exponents. And then the last step is you solve for x. But in this case, we don't have to do much because we're in our final step. X equals 2. Okay, so those are 3 steps we follow in order to solve exponential equations. So for 1.2, step number 1 says we want the same base. What is our base going to be for number 2, 1.2? For number 1.2, what is our base going to be? 4. Thank you very much. So on my left-hand side, I already have a 4 to the power of negative y equals, how do I rewrite 16 with a base of 4? It is 4 to the power of 2. Nice. Okay. So then we have the same base, so we can drop them and equate the exponents. That means make the exponents equal. So then negative y equals 2. Have we solved this? Are we done with this? No. What else do we still need to get rid of? The negative. Thank you. And how are we going to do that? We have a negative y that we need to get rid of that negative. How are we going to do that? Divide. Nice. So then we're going to say negative y and we're going to divide it by negative 1 to get rid of that negative. And then what we do on the left, we have to go do on the right. So then this will be 2 divided by negative 1. Therefore, my final answer y will be equal to final answer, your y will be equal to, nice, negative 2. Beautiful, guys. And now we're on 1.3. We have a problem there with 1.3. What is the problem? What is this dot next to the 3 and the 4? This dot at the bottom over here, what is this dot for? It means multiply. Okay, so we're multiplying stuff on the left. Now we want this term, we want the power with the x to be on its own. So how am I going to get rid of that 3? If I want my 4 to the power of x to be alone, how will I get rid of the 3 that is next to it, that we have multiplied by? I'm going to bring it over, yes, and then when it gets to the next side, what happens with it? If it is currently multiplied by 3, then it's going to become, oh, be careful. Remember, minus is an inverse operation of plus. Are we adding 3 in this case? No, we are multiplying. So what is the correct inverse operation for multiplication? Divide. Thank you. Because, guys, if I divide by 3 here, what's going to happen with these two 3s? Nice. They're gone. Okay, it's going to divide into each other and you're going to be left with 1, which means 4 to the power of x will be left alone. Do you guys see that? So we divide if we are multiplying so that they cancel each other out and we are left with 1 times 4x, 4 to the power of x, which is 4 to the power of x. And then on the right-hand side, we then have 192 divided by 3. And how much is that going to give us? Teacher has to bring her calculator to class. Oh, thank you. Thank you very much. 64. Okay, now we have nothing else to get rid of on my left-hand side. We want same bases. What is my base going to be in this case? 4. So I have 4 to the power of x is equal to 4 to the power of 3. Nice, stable. Beautiful. And now we have two bases that are the same. So step 2, I can drop my base and make my exponents equal, but there's no other step after that. So I can then say, therefore, x is equal to 3. Okay. Thumbs up, thumbs down on first few set of sums that we have done. 1.1, 1.2, and 1.3. Okay, I see some thumbs up. It's all right, Seth. I see your message. Bongo Musa, do you have a question?
Yes, ma'am. Ma'am,
Okay.
them on the fraction, ma'am. How
Yeah.
did you? How are we going to? Yes, ma'am. Are we going to cancel the trees? Oh,
Yes, because remember we divided by 3, right?
yes, ma'am.
So if you say 3 divided by 3, what's your answer?
1.
1. So then you'll be left with 1 times 4 to the power of x. And 1 times 4 to the power of x is just,
4.
well, 4 to the power of x. So do you see why we do it?
Yes, ma'am. Thank you, ma'am.
You're welcome. Wonderful. I saw all our thumbs up, so it means we can move on. Now, for the second part of this, right? The second part of this, we now have surds, which are part of exponents, okay? So square roots, cube roots, they're all part of exponents. So let's look at what we have here. We have 3 cases, similar numbers, but you're going to get a different answer, and we have to discuss why that is going to happen. Okay, we need to discuss why that's going to happen. So let's look at the first one. Number 1 says 16 plus 9 all square rooted. So how are we going to solve number 1? Our solution for number 1 will start with what? It's going to start with everything that is under, thank you, Buhlale, by adding everything under the square root. Okay, so I'm going to leave the square root here and I'm going to say 16 plus 9. How much is that? 16 plus 9. That's 25. So now I'm left with the square root of 25, which gives us an answer of, thank you, of 5. Beautiful. That's number 1. When you look at number 2, this time we have split up my square root. Okay, so square root of 16 plus square root of 9. So now, do we start with adding in this case? No, we start with, we definitely do not add it first. We root them first. Thank you. So what's the square root of 16? It is 4 plus the square root of 9 is 3. So my final answer is then 7. Do you see that it's not the same answer as question 1? It's not the same answer as question 1. So if you are adding under a square root, you are not allowed to split them up. That's not how it works. Okay, you can only split them up when you are doing what? When are you allowed to split the sum up? Does anyone know? Thank you, Seth. When you are multiplying or doing what? Dividing. Is that not the same as the distribution law? Do you guys remember we said if you have 2 times 3 all squared, you're allowed to distribute this guy, right? So in the same way, if you have a big square root here that says 25 times 16, you are allowed to distribute this guy. So you're allowed to say 25 times the root of 16. Is that not easier to work out than trying to multiply this whole sum out? It is much easier to say, well, then this is 5 times 4, which is 20. But if you had to first multiply inside, you would say, well, then this is the square root of 400, which is still 20. But it's easier for you to know that you are allowed to split these up. So this is an extension of the distributive law. Do you see why I needed to do this? This is an extension of distributive law of exponents. So when you're multiplying or dividing, you are allowed to split up your square root. So if I have, it is the same answer, Ilham, but it's possible that your teacher will give you this and say, no calculators allowed. Now, instead of wasting your time and going to multiply 25 by 16, don't you think it's more useful to know that you can split these up? I think that is a more useful solution than anything, right? It's the same as if you have something like 36 divided by 9 all square rooted. It's easy to divide 36 by 9, I admit, right? That is quite easy. But you are allowed to just say that square root of 36 divided by the square root of 9, which will give you 6 over 3, which is 2. But if you have bigger numbers will take you way longer to divide. So I think it's useful for you to know this extension of the distributive law. So whether it's an exponent or it's a surd, we call these square roots surds. Okay. Whether it's an exponent or surd, you can apply this law of exponents. Okay, so number 3 is where they have multiplied them. And in this case, we are allowed to use calculators. So what is the square root of 1,296? 1,296, if you just square rooted it is 36. Okay, so it's easy with a calculator, but it's useful to know the splitting rule. All right. Now let's look at this guy. This is a similar one to what we just did. But now we have variables. So of course, I'm going to make life a little bit more interesting for us. Okay. So let's see here. Number one, am I allowed to split number one? No, we just established you can't, right? So we have to add our like terms. You guys see that these are like terms? These are like terms, okay? X squared and x squared are like terms. So for number one, I have 5x squared plus 4x squared. And now what's that going to give us? 5x squared plus 4x squared is going to give us, thank you, 9x squared. Do you guys think we're done with solving the sum? No. Can we solve the square root of variables? Is it possible to find the square root of a variable? Yes. Does anybody know how we do that? Nice. Beautiful. Okay, so I'm going to first split up my square root and I'm going to first distribute it, okay? So I'm going to first distribute the square root. So I'm going to say this is the same as the square root of 9 times the square root of x squared. Do you agree that 9x squared is 9 times x squared? So I'm allowed to split this up, right? So I have now split this up. So this will equal, the square root of 9 is easy enough. What's the square root of 9 equal to? It is 3. And now what's going to happen with this variable over here? Someone said divide, which makes me think you've done this before. Nice, Tebogo, that's just x. Is there anyone who doesn't know how we found that x? Anyone who has no idea how we found that x? Seth. Okay, Seth. This is the rule with square rooting and cube rooting. Actually, any root for exponents, okay? So I'm going to explain it down here. So if you have an x squared and you are square rooting it, you are allowed to divide whatever exponent you have here by whatever number that's in front here. Now, if there's nothing there for a square root, what number is there? Who knows what that is? Thank you. It's a 2, right? So this will be the same as x to the power of 2 divided by 2. Maybe I should keep the color code so that you know which 2 comes where. So we have x. Nope, this is too thin. X to the power of 2, which was the original one. And we're going to go ahead and divide it by the 2 that was outside. So what's 2 divided by 2? Then it's just going to give us an x. Do you see, Seth? Hopefully, I've just made it clearer for you. So this works with every single square rooting or cube rooting of a variable. So if I have, let's say, x to the power of 9, and I am cube rooting it, what am I going to divide my exponent by? What am I going to? Thank you. So it's going to be x to the power of 9 divided by 3, which is going to give us an answer of, it says, what if it's x cubed? I'm coming just now. It's going to give us an answer of x cubed. So, Tebogo, if you have x to the power of 3 square rooted, you can still apply the rule, okay? This will still give you x to the power of then 3 divided by 2, and you can leave it like that. Because you don't know what x is. Do you agree? We have no idea what x is. So you can literally just leave it as x to the power of 3 divided by 2. And unless you know what x is, you can't substitute, you can't do anything about it. You just have to leave it there. Did I answer your question, Deboho? I hope so. You're welcome. So does this make sense for everyone? Well, to everyone. Oof. And English is not Englishing, guys. It's the end of the week. Does this part make sense to everyone? I see some thumbs up. There we go. All right, so this is how we square root the variables. We're not just guessing, there is an actual method to that. So let's look at number 2. Okay, we have variables on both terms. So we're gonna have to use our square root before we add. Why am I square rooting before we add? Where do surds come in BEDMAS? In BEDMAS, where do we fit surds in? They go into exponents. So this is exponents and surds. So you have to solve them before you add, unless your plus is inside the surd. Then you have to do the other way around, okay? So for number 2, what is the square root of x squared? It's just x plus the square root of 81w to the power of 4. So this is the same as the square root of 81 times the square root of w to the power of 4. What's the square root of 81? 9 plus 9, and square root of w to the power of 4. W squared. Nice, guys. We're getting it. Can we go any further with the sum? No, they're not like terms, so we cannot add them. We can't do anything with them. This is as far as these sums go. Okay. And for the last one, number 3, we have a square root with 3 bases inside. So I'm going to split them up and say it's the square root of 9 times the square root of x squared times the square root of y squared. And then the square root of 9 is going to give us 3 square root of x squared, x, and the square root of y squared, just y. Simple and straightforward. Okay, screenshotters, you may do your thing. If you have any questions, now's the time to ask. You guys are getting this very quickly, so I'm glad. All right. Now let's get going to normal revision of exponents. All right, there's a lot going on here. Where do we start? Where do we start? Do we have any brackets? No. Do we have any exponents that we can simplify? No, we don't. So someone, Seth, suggested we start with division, which is okay as well. We can start with division. Now, if you look at the first division over here, can we do anything about those numbers? I have a -3 divided by 2. Do those have a common factor? No, they do not. Okay, so I'm just going to leave it the way they are. I'm going to put this -3 in my numerator and my 2 in the denominator. Now we have a c at the top and at the bottom, and we are dividing. So we're going to do what with the exponents? How many terms are in this expression? How many do you think are in this expression? How many terms do we think are in this expression? Nice, Botlali, there's only one term. Why is there only one term? Remember, what separates terms? Let me not use the word divide. What separates terms? Thank you. Only pluses and minuses. So this whole thing is just one term. That's correct, guys. There we go. Now, I'm going to subtract these exponents. So I have a c to the power of 1 minus 3. So c is going to be to the power of what? 1 minus 3, which is -2. And then everything else, no, there's x. X to the power of 3 minus 2, which is going to give us x to the power of 3 minus 2, which is 1. So I'm just going to leave it as an x. And then in my denominator, I have a squared that I'm just going to rewrite. Okay, we've dealt with the green part. So now let's do with the blue division. We have a 9 and a 3. Do they have a common factor? 9 and 3, do they have a common factor? Which is what? What's my common factor between 9 and 3? It is 3. It goes into itself how many times? Once, and into 9 3 times. Where is the -2 coming from? Says Bongo Musa. Because we had a c to the power of 1 in the numerator and c to the power of 3 in the denominator. And since we're dividing, you subtract your exponents, so it will be c to the power of 1 minus 3, which gave us -2. Okay, oh, it's 2 to the power of 3. Oh, but we can simplify that, guys. What's 2 to the power of 3? I didn't see that. What is 2 to the power of 3? It is 8. Thank you very much, Seth. So we have an 8 in the bottom. I hope I answered your question, Bongo Musa. Okay, now let's get going. So we said it goes into 9 how many times? 3 times. Okay, let me do this. 3. So in my numerator, I will then be left with a 3. And then we have a to the power of 2 minus 1. So I don't know why I'm writing with blue. You're welcome, Bongo Musa. Which is 1. Thank you. So it's just a. B to the power of 2 minus 2, which is a 0. So I'm going to write it for now. We'll simplify it in the next step. And c to the power of -1 minus 3. So it is -4. And this will all just be over 1. So I'm not going to write it. I'm just going to write it as it is. Actually, let me just write it because we're about to multiply. So now we've divided and we have to multiply. I'm going to start in my numerator. A negative times a positive is going to give us what type of answer? It's going to give us a negative. 3 times 3 is 9. And then we have A that doesn't have a partner. And then B, my A and my 9 look very similar. They're confusing me. That looks terrible. What's B to the power of 0 going to give us? 1. So this is times 1. I'm not going to write it down. And then C, if we're timesing, what are we going to do with these exponents? We're going to add them. So it's going to be C to the power of -2 plus -4. Okay, and then we have an X. Okay, and then in my denominator, I just have 8a squared times 1, which is going to give us 8a squared. Okay, now let's go to the next step. Over here, this plus minus situation is going to do what? It's going to give us a minus. But let's look at my a first. It's going to be a to the power of what minus what? 1 minus 2. So my new exponent for a is, we're back to dividing. A to the power of 1 in the numerator minus 2 in the denominator. And that's going to give us what? -1. Okay, B is gone. And then C, you guys said this plus minus situation is going to give us a negative. So it's going to be -2 minus 4. How much is that? -6x all over 8. Now, do we leave our answer the way it is? No, we want positive exponents. So, which ones are going to move? Tell me which variables are going to move. A and C. So my numerator, I'm going to be left with -9x all over 8ac to the power of 6. Beautiful. Beautiful, beautiful. I feel like we're having an algebra lesson all combined with our exponents lesson. Okay. Hopefully we're doing well over there. If you have questions, remember, don't hesitate to stop me and tell me that I have lost you. And then we will try and find you. Okay, let's move on to B. Where are we going to start with B? With B, we're going to start with B is bracket. Is there anything inside brackets that we can simplify? By the first step, would the answer be the same if I brought the exponent down first? First step. You mean c to the power of 1? Here, like c to the power of -2 and c to the power of -4. Like if you brought all these down, is that what you mean? Yes, you would get the same answer. That is perfectly fine. Okay. You're welcome. So is there anything inside these brackets that we can simplify here? Inside the brackets, do we see anything that is simplifiable? Is it too small for us to see? Maybe I should zoom it out a bit. No, there isn't, right? There isn't anything we can simplify. We're done with brackets. Exponents. Is there anything we can do with exponents? Distribute. So we have a squared here to distribute. We have a -2 there to distribute. And we have a cube here to distribute. Now let's get going. So then I'm going to have 2 squared times x squared times 4y squared all over 5 x to the power of -2, y to the power of -2 times x cubed, y cubed. Thumbs up, thumbs down. Are we all still with me? All I did was distribute. Are we all still with me? Okay, I see a few thumbs up. Thank you. Wonderful, wonderful, guys. So all we did was distribute. And from here on, I'm going to first simplify before we start moving stuff around. Okay, so what's 2 squared? 2 squared is going to give us a. So it's 4x squared. And that's actually all I can simplify times 4y squared over 5 to the power of times, excuse me, x to the power of -2, y to the power of -2 times x cubed, y cubed. Okay, now where do we go? We have the option of first multiplying or first dividing. Seth already says multiply. Stop complicating life. So let's multiply everything in my numerator first. We have a +4 times +4. That's going to give us times, not add, be careful. That is 16x squared y squared. Okay. Divided by 5 is on its own in the denominator, but we do have an x and a y. What happens when we are multiplying? We do what with my exponents? We're going to add them. We're going to add those exponents. So I have x to the power of negative 2 plus 3. Okay, actually, what's negative 2 plus 3? What's my new exponent for x? To the power of negative 2 plus 3, which is 1. So I'm just going to leave it. And y to the power of negative 2 plus 3, which is also going to give us 1. So it's just xy. Okay, are we done with the sum? What's left for us to do in the sum? Divide. We can still divide. Okay, so this will equal, I'm just starting on a new side because of space. This will equal 16 x to the power of 2 minus 1 and y to the power of 2 minus 1 all over 5. So then my final answer will be 16. What's 2 minus 1? So it'll be just x. Again, 2 minus 1 is just 1, so it'll be just y over 5. Wonderful. Okay. Hopefully we're all still with me here. All right, screenshotters, have we done our thing? Okay. Here's another interesting one. Do we have anything inside brackets that can be simplified? No, so we go to exponents, which is distribution. Thanks, you guys collectively answered my question. So we have a squared here we're going to distribute, and we have a 3 there, cube there that we're going to distribute. So then I'm going to have 2 squared times x squared times negative 1x times 4x all over 2 cubed times x cubed times 2 to the power of 0. Let us simplify my exponents. 2 squared is 4x squared times negative 1x times 4x all over 2 cubed, which is how much? 8 times x cubed, and 2 to the power of 0 is times 1. Wonderful. Okay, so do we start with divide or do we start with multiply? Multiply. So let's go to my numerator. I have a positive, a negative, and a positive. So my answer, my final answer is going to be a what? A positive, a negative, and a positive. Thank you, Seth. My answer is going to be negative. So it's positive times negative, which is negative, times another positive, which is still negative, right? And then my number is 4 times 1 times 4, and that's going to give us 16. And when we are multiplying, what are we going to do with these exponents? We're going to add them. So I'm going to have x to the power of 2 plus 1 plus 1. So my exponent for x is going to be 4. Divided by, at the bottom, I just have 8 times 1. So that's going to give us 8x cubed. Okay, now we can still divide, right? Now we're left with division. Do my numbers have a common factor? Yes, and the common factor is? There is, 2 is a common factor, but the highest one is a 8. Okay, so if you use 2, then that's fine. You're just going to have an extra step to do another common factor. All right, so how many times does 8 go into itself? Once, and into 16 twice. So at the top, I'm going to have a -2. And if we're dividing, what are we going to do with my exponents? Subtract them. So I have x to the power of 4 minus 3. This is all over 1. So my final answer is -2x, because this 4 minus 3 is just going to give us a 1. Well done, Tebogo. Are we all good with this one? Thumbs up, thumbs down. Let me zoom out so you can screenshot the whole question together. There we go. Wonderful. I love the thumbs up. Okay, let's zoom back in so we can see properly. Okay. Now we still have a distribution, but it's all the way on the outside. So instead of starting with distribution here, where would we start? Our very first rule for BODMAS is brackets. Do we have something inside my brackets that we can simplify? We're looking inside the bracket. Is there anything we can simplify? Debajo says no. Everyone else, what do you say? Inside the big bracket. Remember, the curly brackets are also brackets. Yes, there we go. So in the small brackets, no, not so much. But in the big curly bracket, yes, there is something we can simplify, right? This is number what? I've now lost count. Number D. Number D. Okay, let's simplify inside the bracket. Are we going to start with multiplication in the denominator? Hopefully that's a yes. So in my big curly brackets, in the numerator, I'm going to leave it as 6x to the power of 7, y to the power of -3. And now I go to my denominator. 2 times 1 is just 2. And since we are multiplying, what are we going to do with the exponents? Add them. So I'm going to have x to the power of 6 and y to the power of -3 plus 3. Nice, that's a 0. Nope. Of course, I'm going to draw a different bracket. All to the power of 3. Now let's divide, right? We can divide. It's possible to divide. Let me start with my numbers. Common factor. 2 into itself, it goes once, and into 6 3 times, okay? So then I have a 3 in my numerator. Well, I have a 3. My curly bracket looks terrible. Okay, and then I have x and x. We are dividing, so we're going to subtract my exponents. So I'm going to put an x here, and we're subtracting. So 7 minus 6, what's my exponent for x? That's just 1, so it's just x, right? Then I'm going to have y to the power of -3 minus 0. -3 minus 0 is just going to give us a -3. Now, is there anything else inside my bracket that I can do? No, so we have no choice but to do what? Distribute. So I'm going to take this 3, distribute, distribute, and distribute. So then I have 3 cubed times x to the power of 3 times y to the power of what? If I'm distributing, what am I going to do with those exponents that I'm distributing? Thank you, Seth. I'm going to multiply them. So then you're going to have -3 times the 3 that is outside, and you're going to end up with a -9. Then we simplify further. 3 cubed, how much is 3 cubed? 3 to the power of 3 is 27. X cubed, and my y is going to go to the denominator. So it's over y to the power of 9. Okay, that was a beautiful sum. There we go. You guys can take a screenshot. Excuse me. All right. Let's do one again that has to do with surds. This is number E. Okay, this time we're cube rooting. This is not a square root. Pay attention to that little guy over there. So first step, I'm going to split this up to make it easier to solve. Okay, so I'm going to start off by saying the cube root of 54 times the cube root of 60, x to the power of 16, excuse me, x to the power of 16 times the cube root of y to the power of -12. Is there a cube root of 54? Cube root of 54? No. Well, you can work it out, but you're going to get a decimal. Do you guys agree? It is possible to work it out, but it is not a perfect cube. You're going to end up with a decimal still. Okay, so if you work it out with your calculator, round it off to 2 decimal places, tell me what the answer is. My cube root for 54, 2 decimal places. Remember, teachers love these type of questions because as soon as you get a decimal, you guys start doubting. And then you start thinking you're doing the wrong thing because just because there's a decimal. So it is possible to still cube root it. It's just not a perfect cube. So yes, indeed, Ashley, you're going to end up with 3 times 3, 78 times x to the power of 16 over 3. Why am I leaving it as 16 over 3? Because I can't exactly divide 16 by 3, right? And then it's going to be times y to the power of what? What's -12 divided by 3? -12 divided by 3. It is -4. Are we done with answering this question? Are we done with answering this question? No. What can we still do with this question? We can. What can we still do with this question, guys? We can move the y. Can you see the y has a negative exponent? So we can move the y to the denominator so that it ends up with a positive exponent. Okay, so this will then be 3,78. You can still leave it as the cube root of x to the power of 16 if you want, or divided by y to the power of 4. Okay. Hopefully we are still with me here. Okay, I feel like we still have time to do another one. Oh, that's an interesting one. This is an interesting one. Let's hear thoughts. I almost said thoughts and prayers. You guys. Thoughts with this one? This is an exponential equation, right? How do we know it's an equation? How do we know this is an equation and not just an expression? Because of the equal sign. Okay, we'll get there when we get to algebra. This equal sign is telling you it's an equation. So you need to try and solve it. Okay, so then I have 7x plus 2 equals. We want the same base on the side. What base do you think that base is going to be? What base do you think that base? Wow. What base do you think we're going to have to work with here? If we want the same base on both sides, then what base do you think that is going to be? Back to E. There we go. Guys, with my last one, my base is going to be a 7. Now we have learned how to find our prime factors using the calculator, didn't we? Did we? Have we learned how to find prime factors using our calculator? Yes, so let's find the prime factors of 343 while I wait for Elam's question. Let's find the prime factors of 343. Nice, Butlali. It is 7 cubed. For those who forgot, you go on your calculator, Casio. You can say 343. So you say 343. You press equals. You press the shift button. And you press the one that has a fact on top, which is factors, by the way. That fact stands for factors. It's the one with the dot and the commas and what. Okay, so then it's going to give us 1 over 7 to the power of 3. But I don't want 1 over 7 to the power of 3. I want a base of 7. So how can I move this to the top? What's going to happen with my exponent over here? If I move this 7 to my numerator, then exponent is going to become negative. Nice, guys. It's going to be negative 3. So now we have our same bases. So what will we do? We drop the bases. So then x plus 2 will be equal to negative 3. How will we solve for x? How are we going to solve for x? Substitute 2, no. I need to get rid of this 2. I want it to go to the other side. But how am I going to do that? The inverse operation, what's inverse of addition? Subtraction. So x plus 2, you're going to minus 2 this side. Negative minus 2. What's plus 2 minus 2? 0. So the 2's are gone. So you're left with, therefore, x is equal to negative 3 minus 2, which is going to give us a negative 5. Beautiful.